Assalamu alaikum. My name is Ali Khan, roll number 21TE77. Today we discuss the lab number 5 of DSP. In task 1, first of all we define a function which is my DFT, then define length, then define zeros, then starting for loop k, then starting another for loop, then we define a function that is a built-in function in matlab, that is y into x of plus 1 is equal to y into k plus 1 plus x into n plus 1 into exponential of same values. Then ending for loop. Now we define inverse DFT same like previous. We define length, then define zeros, then starting for loop which is n is equal to 0 to n minus 1, then starting another for loop that is k is equal to 0 to n minus 1, then define built-in function, then end the function. The only difference between DFT and inverse DFT is minus sign plus there is another into x into n plus 1 is equal to x into n plus 1 over n, then ending that for loop. Then we define for x defining each of them. First we define 1x, that is 0, 3, 4 and 5. The defining y is equal to my DFT, that we display the DFT coefficient using display built-in function that calculated the inverse DFT, that we define x is equal to my inverse DFT. Then we display the reconstructed sequences. So we get an output. Before that we take second x and defining y, then display the DFT coefficient, then calculate inverse DFT, then display the reconstructed sequence, then taking third x, that is 1 2 3 2 3 4 1 2, same like previous one, that display DFT coefficient, that display the reconstructed sequences, then taking last x and range is x is equal to 1 0 minus 1 minus 2 0 1 1 and 2. Then display my DFT, then display DFT coefficient, then display the inverse DFT, then display the reconstructed sequence as a result. We get 4 output and 4 input. Same like this output DFT coefficient, and this is the inverse DFT sequence, and output 2, this is the DFT coefficients, and this is the inverse DFT sequence. This is DFT coefficients, and this is the inverse DFT sequence. Output 3. This is the DFT coefficients, and same like this is the inverse DFT sequence. Output 4. This is the DFT coefficients, and this is the IDFT sequence. Now we move toward the task number 2. So in task number 2, we have range of x from x1 to x11, and we define all in the sequences. Then use figure for figure, then we plot. That's why we use stem command, then give title is a result. We get output to define for every x from x11 from x1 to x11. Then use stem command, then title, and this is the result is shown. Now we move toward the task number 3. In task 3, we use same built-in function of matlab, that is f of t, that is first Fourier transform, that is that that is we define x is equal to 1, 2, 3, and 4. Then use built-in function built-in command of matlab. A first Fourier transform as a result we get output. Secondly, actually we plot real term, for that we use reveal as a result. We x real v is a result v is a result x real, then find x imaginary, and x imaginary, for that we also use x imaginary, and we get x imaginary terms. Finally, we get absolute term n of x, for that we use built-in function, that is f. As a result we get absolute term. Now we move toward the task number 4. Here in task number 4 is same like task 2 with some iteration. First we define x from x1 to x11. Then we separately define from x1 to x11 as on FFT. As an FFT, that is the built-in function of MATLAB. So define these from x1 to x11 as in term of FFT. Then we separately define each of them from x11 to from x1 to x11 in magnitude, phase, and power. So we define it from x1 to x11, and after defining plot all these. For this we use subplot 3 1 1, then use stem command, then give title, that labeling of x-axis and y-axis, then again use subplot, that is 3 1 2, that give title x label and y label, that then again use subplot 3 1 3, that is title and x labels and y labels. As a result we get output of magnitude, spectrum, phase spectrum, and power spectrum. So this is In the output, we get magnitude spectrum, and this is the phase spectrum, and this is the power spectrum. So that is all about the lab number 5. Thanks for watching.